In this lesson, we will evaluate an infinite geometric series. So you're going to find that this is very similar to what we had before. The only difference is before, in our numerator, we had 1 minus r to the n, and we no longer have that. So we have just a to the first, or the a sub 1 on the top, and then 1 minus r on the bottom. So obviously this is one that you would write down, but a very, very important thing here is that if the absolute value of r is greater than or equal to 1, then the sum does not exist, because those values would keep getting bigger and bigger and bigger and bigger. So for instance, on this one, my r value would be -3/5. So if I took the absolute value of 3/5, that's obviously less than or equal to 1, so I can find the sum. So to find the sum, I'm going to take a sub 1, which is -6, and 1 minus r, so r is -3/5, and that's going to give me the sum. So my numerator is -6. I have 1 minus -3/5, so I'm actually adding. So that's 5/5 plus 3/5, which is 8/5. And this is -6. Instead of dividing by 8/5, I'm going to multiply by 5/8. And that's going to give me -30 over 8, which reduces to -15 over 4. So that is the sum of all of those terms onto infinity. Here's another for us to try. Again, this one they're giving me the actual series. I need to find a sub 1, which is 4. I also need to find r, so I'm going to take -6 divided by 4, which is -3/2. I could double check 9 divided by -6, which is -3/2, etc. So again, that means r is -3/2. The absolute value of -3/2 is 3/2. And unfortunately, that is greater than or equal to 1, which means this is not possible. So always double check to see if it's possible before you start plugging it into your function. Here are two for you to try, so try them both and then press play to check your work. So again, this one, I've got a sub n, or a sub 1, excuse me, is 2. To find the common difference, I'm going to take 5/2 divided by 2, which would be like 5/2 times 1/2, which is 5/4. Again, I could double check that, but that is my common difference. If I take the absolute value of 5/4, I get 5/4, and that, of course, is greater than or equal to 1, so that is not possible. And for my other, the common difference is 3/4. So, the common ratio is 3/4, which means I can find the sum. So now I'm going to use my function here, which says to take my first term, which is 4, and then 1 minus whatever my r is, which is, in this case is 3/4. So that gives me 4 divided by 1 minus 3/4 is 1/4. So really that's 4 divided by a 4th, or 4 times 4, which is 16. So the sum is 16.